Hi everyone, and welcome to this video going over lesson 31-2, regular polygons and exterior angles. A polygon is considered regular if it is both equilateral and equiangular. Equilateral means that all of the sides are the same length, and equiangular means that all of the angles are equal. And so a polygon that has all equal sides and all equal angles is considered regular. And if we know that all of the angles are going to be the same measure, we can just divide the interior angle sum by the number of angles to find out what each interior angle is going to measure. So let's practice this. In the last video, we said that we can find the sum of the interior angles of a polygon by multiplying 180 by the number of sides minus 2. And so we should be familiar with octagons at this point. Octagons have 8 sides. And so I'm going to multiply 180 times 8 minus 2. And this tells me that the interior angle sum of an octagon is 1,080 degrees. If we have a regular octagon, that means that all of the angles are the same measure. And so if we divide our total by how many angles there are, which is 8, I can figure out what each angle will measure. And so 1,080 divided by 8 tells me that each interior angle will be 135 degrees. And so I'd like you to practice this. I have a list of different polygons here, and so we're also going to start to learn the polygons' names. A 3-sided polygon is called a triangle, and all of the angles inside of a triangle add up to 180 degrees. And so if we do 180 divided by 3, it tells me that each interior angle of a regular triangle will be 60 degrees. And if you're wondering where I got the middle column, all of the sums, that was from the last video when we did 180 times n minus 2. So instead of doing that part again, I just stole those answers from the last video, but if you want to check my work, all you have to do is take the number of sides and subtract 2, and then multiply by 180. A 4-sided polygon is called a quadrilateral, and all the angles of a quadrilateral add up to 360 degrees. So if we do 360 divided by 4, it tells me that all of the interior angles measure 90 degrees for a regular quadrilateral. A 5-sided polygon is called a pentagon, and its interior angle sum is 540 degrees. And so 540 divided by 5 tells me that for a regular pentagon, each angle, or each interior angle, measures 108 degrees. A 6-sided polygon is called a hexagon, and its interior angle sum is 720 degrees. 720 divided by 6 tells me that for a regular hexagon, each interior angle is 120 degrees. A 7-sided polygon is called a heptagon. Its interior angle sum is 900 degrees. 900 divided by 7 tells me that each interior angle of a regular heptagon will be 128.57 degrees. We already saw above that an 8-sided polygon is called an octagon. Its interior angle sum is 1,080 degrees. Divided by 8 tells me that each interior angle of a regular octagon will be 135 degrees. A 9-sided polygon is called a nonagon. Its interior angle sum is 1260 degrees. Divided by 9 tells me that each interior angle of a regular nonagon will be 140 degrees. A 10-sided polygon is called a decagon. Its interior angle sum is 1440 degrees. Divided by 10 tells me that each interior angle of a regular decagon will be 144 degrees. And lastly, a 12-sided polygon is called a dodecagon. Its interior angle sum is 1800 degrees. Divided by 12 tells me that each interior angle of a regular dodecagon is 150 degrees. So once again, if we know the polygon is regular, then all of its angles have the same measure. So we can divide the interior angle total by how many there are, and it will tell me what each interior angle measures. Let's move on to discuss exterior angles. An exterior angle is formed by extending the sides of my polygon, and notice how it's formed outside of the polygon. That's why it's called an exterior angle. And what I want you to see is that each exterior angle and each interior angle form a linear pair, which means each interior angle and each exterior angle are supplementary and add up to 180 degrees. So let's think about this. If this polygon is regular, it tells me that all of my interior angles are congruent. And if we just subtract our interior angle from 180 to find out our exterior angle, then all of the exterior angles will be congruent as well, because each time I would just be subtracting the same number from 180, which means all of the exterior angles will be congruent if all of the interior angles are congruent. So in part B it says find A. Well, if I can find the interior angle first, I can just subtract the interior angle from 180 to figure out what the exterior angle is. So this looks to be a 1, 2, 3, 4, 5, 6-sided polygon. So I am going to multiply 180 times 6 minus 2, which tells me all of the interior angles add up to 720 degrees. To find out what each interior angle measures, I'm going to divide 720 by 6, and this tells me that each interior angle measures 120 degrees. But the question didn't ask about interior angles. They want A, which is the exterior angle. Since each interior angle and each exterior angle form a linear pair, I can just subtract 120 from 180 to find out what the exterior angle is. And this tells me that my exterior angles are all 60 degrees. And so we just said all of the exterior angles are congruent because all of the interior angles are congruent. So to find the sum or the total of adding up all the exterior angles, I am just going to multiply 60 by 6 because I have 6 exterior angles. And I get an exterior angle sum of 360 degrees. And so I want to practice this same process with a couple other polygons. So I have this table here. We already found the measure of each interior angle in the table from the first page of this video. So I'm just going to copy those values down. Each interior angle of an equilateral triangle is 60 degrees. Each interior angle of a regular octagon is 135 degrees. And each interior angle of a regular decagon is 144 degrees. So to find the exterior angle, all I have to do is subtract 60 from 180 because the interior and exterior angles form a linear pair. And this tells me that each exterior angle will be 120 degrees for an equilateral triangle. And then to find the sum of the exterior angles, I'm just going to multiply that 120 by how many there are. And so because I have a triangle, which is 3 sides, I have 3 exterior angles, which gives me a total of 360 degrees. For the octagon, I'm going to subtract 135 from 180, and this tells me that each exterior angle is 45 degrees. And then because I have 8 sides, I have 8 exterior angles, So 45 times 8 gives me an exterior angle sum of 360 degrees. Last one, I am going to subtract 144 from 180 to get that the measure of each exterior angle for a regular decagon is 36 degrees. And then I will do 36 times 10 to find out the sum of the exterior angles of a regular decagon, which is 360 degrees. Notice how I got 360 degrees as the exterior angle sum for every single polygon? That is no coincidence. The sum of the exterior angles of a polygon, and that's any polygon, regular or not, is always 360 degrees. So make sure you know that the exterior angles of any polygon will always add up to 360 degrees. And this can come in handy if we know that they always add up to 360 degrees, and we know that the polygon is regular, we can just divide 360 by the number of sides to find out what each exterior angle will be. For example, Gerardo drew a regular polygon that had exterior angles measuring 40 degrees. How many sides did his polygon have? So, I know that the exterior angles will always add up to 360 degrees, and I know that they each measure 40 degrees. So I need to figure out how many times I have to add 40 to get to 360 degrees, which means all I have to do is divide 360 by 40, and this tells me that my polygon will have 9 sides. And we saw on the first page that a 9-sided polygon is called a nonagon. In part B, it says a polygon has an interior angle sum of 2,520 degrees. Now this should say a regular polygon. A regular polygon has an interior angle sum of 2,520 degrees. How many sides does it have? Well, the interior angle sum formula is 180 times n minus 2, and we are told that whatever n is, this equals 2,520. And all I have to do is solve for n. So I'm going to distribute this 180 to get 180n minus 360 equals 2,520. I will add 360 to both sides to get 180n equals 2,880. And then I will divide by 180 to both sides. And this tells me that this polygon will have 16 sides. In C, it says a quadrilateral has 4 sides. What is the measure of each of its interior angles? Now notice, it just says a quadrilateral has 4 sides. It doesn't mention anything about the quadrilateral being regular, and it doesn't mention that the 4 sides are congruent. So here we do not have enough information, because if we know it's regular, we know all of the angles will be the same, but if we don't know if it's regular or not, we have no idea what each interior angle will be. They could all be the same, or they could all be different, but we don't have enough info, so we can't proceed with this problem. And then lastly, we have D. What is the measure of an interior angle of a 360 gon? Whenever we have a polygon with more than 12 sides, they just put the number of sides dash gon to represent how many sides the polygon has. So this polygon has 360 sides. What I'm going to do is I'm going to find the interior angle sum by doing 180 times 360 minus 2, which tells me all of the interior angles add up to 64,440 degrees. And then if I divide by 360, this will tell me what each one measures. And so each one measures 179 degrees. Now the question asked, is there more than one way to find this answer? And the answer is yes. We did this by using the interior angle sum formula, but we also know that if this polygon has 360 sides and we divide by 360, each exterior angle will be 1 degree. Then if I just subtract 1 from 180, I'll find out what each interior angle is, because I know that each exterior angle and each interior angle add up to 180. So I always like to say, in math, there's more than one method sometimes to solve a problem, so choose the method that makes you the most comfortable. And what we just saw is that all the information we have is connected. The number of sides, n, can tell us the measure of each interior angle or the measure of each exterior angle. And notice how these arrows are double-sided, which means you're not always going to be given the number of sides, but you could be given the measure of each interior angle or the measure of each exterior angle, and you should be able to find all the other missing pieces of information. I'm going to make you a quick list of all of our formulas that you can refer to, and you can assess when you're given a problem what you are given and what you need to find, and then you can choose the right formula that fits. So to find the interior angle sum, which is all of the interior angles added up, we are going to do 180 times n minus 2. To find the measure of each interior angle for a regular polygon, I'm going to do 180 times n minus 2, which tells me the total, and then divide by how many I have. To find the measure of each exterior angle for a regular polygon, since I know that all of the exterior angles always add up to 360 degrees, I can just divide 360 by how many I have, and it'll tell me what each exterior angle measures. I also want you to note that each exterior angle and each interior angle added together will equal 180 degrees because they form a linear pair. So those are your formulas to find the missing angle measures of polygons, and most importantly, for regular polygons. Please let me know if you have any questions, and I will see you in class.